Hello and welcome back. So in this second video, we're going to be talking about much the same concept as what we did before, except instead of just being given a point and a gradient, we're going to find the equation of a line between 2 points. So it's basically an extra step to what we had to do before. So it's not too hard, but we're going to use very much the same concepts. So in the last video, I talked to you about being able to find the equation of any line if you're given a single point and you're given a gradient. Well, in this particular case, you're going to be given two specific points, and I'm going to tell you why that's essentially the same thing as what we were doing before. If I'm given a single point, and I'm given a gradient, we could find the equation. However, if I'm given 2 points, I can find out the gradient, and then use one of the points in the point gradient form. Okay? So, here's my steps to show you how we're going to find the equation of any line that goes through these particular points here. So the first step that we'll always do is we're going to find the gradient. Remember, that's a whole rise over run, or in most cases we're actually going to use this formula here. Okay, m equals y2 minus y1 over x2 minus x1, and that just finds the rise over the run for us. Okay, then we're going to sub y minus y, sub everything that we find, so our gradient, into this formula and one of the points. I really want to highlight this. It doesn't matter which point you sub in. Okay, right, and then we will simplify depending on what the question asks. So it might ask us to go for general form, it might ask us to go for gradient intercept. We'll see as we go along. Okay, so let's have a little bit of a look at how we're going to do some questions with this. So, find the equation of a line that passes through 1, 3, so here's 1 point, and minus 2, 5. Okay, so we're given 2 points, and we're finding the equation that runs between them. Okay, now you could do a visual of this if you would like. Okay, essentially what this looks like, very roughly, it looks something like this. Okay, I'm just drawing a very rough Cartesian plane so you can see what's going on. So through the point 1, 3, so we go across 1, up 3. Alright, and then through the point minus 2 and 5, so we go across minus 2 and then up 5. We're finding the equation of a line that looks something like that. Okay, it's just a very rough sketch so you have a bit of an idea of what's going on. Okay, so let's actually start having a little bit of a look at it, right? It asks us to give our answer in both general form and gradient intercept. So it doesn't matter which way we write this in this one, we're going to be writing it in both, and I'll show you as we go along. Okay, so I like to write my points out. I always write my points out. So 1, 3, and minus 2, 5. The reason why I do this is because it allows me to label them. Now, it doesn't matter whether you label this one is x2, y2, and this one is x2, y2. It honestly does not matter. It won't change your answer, just as long as you're consistent with how you apply the x2s, y2s, x1s, and y1s. Okay? Alright, so for example, if I do this one minus that one, I have to do this one minus that one. Okay? And vice versa. Alright? So just be aware of that. It won't affect your final answer as long as you're consistent. Alright? So I do the labeling to make sure that I am consistent in my answer. Alright, so let's have a little bit of a look, right? Step 1, we're going to find the gradient between the 2 points. We need to do that because we want to use a point gradient formula. We only have a point, we don't have a gradient. So just remember, alright, step 1, we're going to find m. Well, that's just y2 minus y1 over x2 minus x1. Okay? Which is equal to, so now we just sub everything in. My y2 is 5, minus my y1, which is 3, all over my x2, which is minus 2, minus my x1, minus 1. After I do a little bit of simplification, 5 minus 3 is 2, minus 2 minus 1 is minus 3. So our gradient here is essentially the same. It doesn't matter where you put this minus, it can go at the front, on top, it doesn't really matter. Okay, our gradient here is minus 2 over 3. Okay, so the next thing that we're going to do is now that we have our gradient, we're going to sub it into the point gradient form. This thing. Okay? Now, it doesn't matter which point you pick. This y1 and this x1 can actually come from either of these 2 points. I'll say that again. It can come from either of these 2 points. However, what I want to do is I want to make sure that my life is easier because I'm a mathematician and I'm lazy, which means that I'm going to use things where I don't have to worry about negatives, okay? So you'll notice this particular point here has no negatives, so I'm going to use that rather than worrying about this point that has negatives. It'll allow me to make careless errors. So let's do it. So y minus y1, okay? Just remember it doesn't matter about the y1 in this particular case, right? We're just using this first point. So y minus 3 equals m. Well, we found m. minus 2 over 3 outside of x minus x1. Okay, now what we can do from here on out is we can go for general form or we can go for y-intercept. I'm going to go for general form first, and then I'll go from there on out. So I'm going to multiply everything by this 3, okay, right, like I showed you in the last video. So I have 3y minus 3 equals minus 2x minus 1, okay, and I'm going to expand everything out. So 3y minus 9 equals minus 2x minus 2 times minus 1 will become a plus 2. Be very, very careful of that. Okay, so if I'm going to go for general form first, okay, I'm going to bring the 2x over, all right, make it positive. So 2x, all right, plus 3y minus 9 equals positive 2, and now bring the minus 2 over, so 2x plus 3y minus 11 equals 0. So that's general form, okay? If we want to go for gradient intercept form, we just need to get y by itself, okay, which is the other part of this question that's asking us for, just to write them both in both forms, okay? So what we're going to do is we're going to try and isolate y by itself. So we're going to move the x over and we're going to move the 11 over, okay, all in one step, just so I can make this a little bit shorter for you guys. So I have 3y, that'll become a minus 2x when we move, all right, and the minus 11 will become a plus, okay? Now I want to get the y by itself. I'm going to divide everything through by 3. So y equals minus 2 over 3x, which agrees with what we were talking about before. All right, and then plus 11 over 3. Just remember that you have to divide both things. Okay, and this agrees, right? So we know our gradient is minus 2 over 3. We established that before. Okay, all right, so here's our general form, and here's our gradient intercept form. All right, depending on what the question asks you to leave it in is what you try and aim for. Okay, but that's the process. So just to summarize, that's the equation of line that goes through these 2 points. All right, you find the gradient first, sub it into the point gradient formula, and then simplify. Okay, so let's do one more. Okay, so this second question just says find the equation of the straight line that passes through the points 2, 5, and 3, and minus 2. Okay, it doesn't give us a specific form to write anything in, okay, so it's up to you. You could choose gradient intercept, or you could choose the general form, okay? So, same thing as before, identify our points, we take them out, so 2, 5, 3, and minus 2, all right? We take the points out, and now we start working on them, right? So I like to label them x1, y1, x2, y2. Let's now find the gradient between them. So step 1, m equals y2 minus y1 over x2 minus x1. Again, you can label these either way, it doesn't matter. Okay, so minus 2 minus 5 all over, and now we're going to do x2 minus x1, which is 3 minus 1. Minus 2 minus 5 will give you minus 7 over 3 minus 1, 3 minus 2, my apologies, okay, will give you 1. So your gradient is just minus 7. Okay, so now we're going to sub things in, okay, to our point gradient form. M outside of x minus x1. Okay, so we're going to sub everything in. We're going to use this now. It's up to you which point you pick. You can pick this point here, all right? That is completely and totally up to you. Or you can pick this point here. I'm going to pick this point here to sub into this formula purely because it has more positives. You'll end up with the same answer either way, all right, because it is a unique line, but this one has less things for me to worry about, okay? So y minus y1, well, that's my 5, equals my gradient, so minus 7, outside of x minus x1, minus 2, all right? Now, I notice that I've got all of these whole numbers here. I'm probably going to find it a little bit easier to either to go for general form if I wanted to, or I could simply expand out and add 5. It's completely and totally up to you. All right. In my head, I generally try to go for general form just because that's a habit of mine. So why don't I try and break that in this one? Okay. So let's expand out the brackets. Y minus 5 equals minus 7x plus 14, being very, very careful. All right. And now I'm going to add the 5 to the other side to get y by itself because I'm going to go for gradient intercept form. So minus 7x, and I add the 5, it becomes plus 19. Okay, so gradient intercept form, there's my gradient, there's my intercept. Okay, so that's how you find the equation of a line between 2 points. Okay, I hope you found this useful, and I'll see you next time. Thank you.